Hi, this is a demonstration of the anonymous token feature that we are implementing in Smittestopp. And I will do a walkthrough of some of the essential parts of the code while debugging it. So here is Smittestopp, and I can register as infected. And the magic happens after I'm done logging in. So we've logged in, and as we get the access token back from the server, it checks whether the server has enabled, or this is the verification server, whether it's enabled the anonymous token feature. And if so, it adds a claim to the access token. And when we are now submitting our result, the code in the app will check whether that claim is set or not. So in this case, we can see that the client thinks that it should use a anonymous token. And when using an anonymous token, we post the results slightly different to the server. So first, we need to generate a token request, and the idea behind this token request is that the verification server and the backend should not know which client made a request, but they should still know that this client is a valid client. So this starts with the client generating a request, and the request contains a few cryptographic parameters that are then sent to the server and the validation server, the verification server. And so the verification server gets the request from the client, and then it needs to sign this request. And it does that by using a private key that is generated for this day. And so what we're doing here is that for each day, we're generating a separate private key, and we're generating it in a way that is predictable, so the backend will get the same private key. And when the client has, when the verification server has found the private key, it can take the values from the app and assign them to generate a token that goes back to the client. And it also tells the client which key it used to do this signature. The client now gets the token back from the server, and then it randomizes it in a way that makes it impossible for the backend to know what a client this was. And it encodes it so that when it does the HTTP request to submit the diagnostic keys, it adds that as a header instead of the bearer token header. So we call this header an anonymous token instead. When we get to the backend, we've made a separate upload keys authorization attribute, which is very similar to the authorization attribute, but it also checks for this anonymous key. So if the client uses the anonymous key, we pick out that instead. We decode it. It consists of the signed value, the seed that the client used to generate that value, and the key ID. And if you wonder, I really don't know the cryptography behind this. There's a paper on that. The backend can then generate the same private key as the verification server used to sign this token originally, and then it can verify that the token was indeed signed by the backend. And when we do so, we see that this token here is valid. So that goes the whole way through the verification server to generate the token, to the app which randomizes the token, and back to the backend which verifies the token. And with that, the demo is complete. We've now uploaded our exposure keys using an anonymous token generation.